In this session, our focus is primarily on how do I look at if the two random variables are dependent on each other. I am talking about computing, let's say, var or expected shortfall, especially not for one single variable as we have been seeing till now, but for a bucket of variables wherein each of the variables may be interrelated or the underlying distribution of each of those variables may or may not be normal or any such kind of scenarios. So in those cases, how do I model the dependence between those variables? And how can I use the concept of correlations and copulas in that particular context? Especially if I have to use correlation, because whenever we talk about two variables at a time, the first thing that comes to our mind is it's just not even if I have to compute the value at risk or even variance, we talk about finding the individual variances and then the kind of covariance that exists between them, and the covariance that exists between the two variables is in turn dependent on correlation, right? So as long as we want to look at two variables together, the first thing that comes to our mind is why not check out for the correlation between the two variables. But couple of things I want every one of you to appreciate. The concept of correlation is very good only if you find that the random variables are normally distributed. If the random variables are not normally distributed, the concept of correlation is of not much of a significance at all, because in case of normal distribution, when I say correlation is 0, I can very well consider that the variables are independent. Whereas if the distribution is not normal, if I get correlation equal to 0, it doesn't mean that they are independent. There may be some other form of dependency that might exist between them. So that's the reason one important thing that we have to make a note is correlation makes sense only when the variables are normally distributed. And the other drawback with correlation is, let's say if I am finding out the correlation between the two variables x and y, I got the correlation to be 1. But suddenly I transform these variables, let's say into log x and log y, and find the correlation between the same. I may not get the correlation between the two as 1, probably I may get it as 0.85 or something else, or probably e power x and e power y. I want to find out the correlation between them, it may come out to some other number, which means correlations are not invariant to transformation. They change with the transformation of the original data, which means from a definition standpoint also, it's just a relationship between two sets of variables. Whatever I play on these variables, the correlation should not change. But what we observe from the definition of the correlation, because this correlation is nothing but it's a concept of linear correlation.